In this video, we're going to start talking about functions. Now, functions are found in almost every programming language. Sometimes they're called functions, sometimes they're called subroutines, but they are a way for you to reuse your code without having to type it each and every time. You don't want to just cut and paste lines of code when you have to do something multiple times in whatever program you're doing. Functions have been, at least when I found teaching them, one of the more challenging concepts for many students to get down. And this is one of the reasons I introduce it early, because I think most students need a lot of practice to really understand what's going on. Once you get it, once it clicks for you, it's going to be awesome, and you're going to be like, oh my gosh, this is so helpful. It makes a lot of things easier for you. And so if you're struggling a bit in the beginning, that's okay. You're not alone. I remember I had a lot of trouble really getting and understanding functions. And then again, like I said, it clicks for you and it'll just start coming to you in your programs and stuff. So let me give you a very short overview in a lecture format as to what exactly functions are. Conceptually, you should think of them like Lego blocks. They're a way to break your program up into small, reusable chunks that you can put together as needed, reuse, and even share with others. And later when we get into talking about modules and libraries, all of those, most of them, are really just functions that other people have written. So again, think about functions as bringing a modularity, the idea that you've got all these kind of modules that you can stick together as needed. You actually already use functions when you use your calculator. So for many of you, you might be familiar with this or some similar type of graphing calculator. And there are trigonometric functions. But these functions are actually, at least in the calculator, programmed up as computer functions. So let me now skip from the idea of mathematical functions to computer functions. So when you type in tan, or when you press the button and the little tan appears for tangent, this is a function. You pass in some input to the function. In this case, I'm passing in 0.62 radians. This is the input, and then you get some output. In this case, it's 0.7139. So I have a function, it takes some input and returns some output. And we're going to use this verb returned a lot in this discussion, and there's actually a return Python word that you'll see. So again, I'm going to emphasize this. A function takes input and then returns some output. In Python, the way you code this up is you define a function. And the way you define your function is you actually have this Python keyword def. Okay, so this Python special word def is short for define. It allows you to define a function. And in this case, the function that we've defined is called add numbers. It takes as input two variables, A and B, and notice that there are no numbers assigned to these. It's going to take whatever you pass in for these and then do something with it. And this input is called arguments. So I have two arguments for this function. And then what it does is it returns the sum of A plus B. And we don't have to have numbers. We don't have to say this is 2, this is 3, or 10, or 12.35, or anything at this point. Here we can just treat them almost like algebra, some sort of algebra function. So you return A plus B. And then when you use it, since it returns a value, so here I've got add numbers, 9.8 and 4.7 are the values for the arguments that I pass in, and I take the output and I assign it to a variable x, and if I print x, I get 14.5. Okay, so now we're actually going to try this with some code. So go ahead and get your notebook open and follow along with me. So you may have wanted to have already read through this. I'm just going to go ahead and clear the runtime and also go to edit and clear all outputs just to make sure that there's nothing lingering from this from when I wrote it earlier. Okay, so as I mentioned before, functions are pieces of code. You can reuse them just by calling the name of the function, and you're going to find that this saves you an incredible amount of time because you don't want to have to cut and paste your code all the time. Now, this is where we start to first get into some of the particulars of the Python programming language, and that is that functions make use of white space. That means spaces or tabs. You can think of it as blank space, and you use this to indent the parts of the code that are part of the function. And so any code that does not have the same indentation is not part of the function. You'll see this below, and it helps actually makes the code a bit more readable. If your function returns a value, you can then assign that value to a new variable. That's what we saw in the lecture, the slides. And then when we make use of the function, we're going to refer to it as calling the function. So you'll hear me refer to calling a function, or I may ask you to call the function to test it. And that's what it means to actually use the function. So first we're going to go through some basic functions. We're going to write a function called add. This is very similar to what we saw in the slides. It takes in two numbers, and I'm going to emphasize this again. This input, these variables are called arguments. It's going to take in two numbers and add them together, and it should return the sum of the numbers. So we're going to use def add, and we're going to take in two numbers. Let's call it A and B, and there's got to be a comma between them. And then right here, and this is really important, you have to have a colon. And if you don't have the colon, you're going to get an error. So this is not a semicolon. This is a colon at the end of the function definition. And you'll see if you type this out and you have the colon, if you're in Colab or most Jupyter notebooks, if you hit return or enter, it automatically indents you. And for me, this is set up for 2 spaces for an indent. You could have 1 space if you wanted. I use 2 spaces. Some people prefer 4 spaces. It's a whole thing what people prefer, just so long as everything in the function has the same indentation. So I'll use 2 spaces. And what I will do is I'm going to just return A plus B. And later on, we'll see that I could assign this to a variable and return that variable if I want, but I'm just going to do it in 1 step. And right here, I'm just going to remind ourselves we need this return statement. Otherwise, there will be no output. Okay, so we need that return statement, and then we have everything indented. If I have a new line, that line should have at least a couple of spaces in it as well. And Colab usually adds those for us. Okay. All right, so I'm going to hit Shift Enter. Nothing's actually going to happen because all we've done is we've defined the function. We haven't actually used it. So just like your calculator has tangent defined, nothing actually happens unless you actually press the tangent button. Okay. So once you've got this function written, and make sure you run the cell, you can use this function over and over and over again. So here I've actually typed out already how we're going to use the function. We've got add, and then we pass in 2 numbers here, 10 and 20. It's going to return a value, which in this case we're going to assign to x, and then we're going to print x. Then we're going to use the add function again. We don't have to retype anything. Add has already been defined. We pass in 1.4, 2.9. Notice there's a comma between them. Assign the value to x, and then we print it. And then here, I've got something called result. I've got a different variable. I can call these variables whatever I want. I'm going to use the add function. And instead of passing in numbers, I actually have these 2 strings that say hi there. And we'll see what that gives us. I'm going to hit Control Enter to run it. And we see that if we pass in 10 and 20, we get 30. If we pass in 1.4 and 2.9, we got 4.3. And if we pass in hi and there, we got hi there as 1 string. So again, we defined this function in 1 cell, and then we used it in a separate cell. And of course, we could have had it all in 1 cell if we wanted to. Now in Python, and this is unlike some other languages, you can actually return more than one value, and this is incredibly useful. Now, some of you may have guessed once I said that, but if your function returns 2 or more values, you could return 3, 4, 5, 20. If it returns 2 or more values, you want to assign those values to 2 or more variables, and I'll show you how to do that in the next step. So let's run an example. Let's do an example where we want to convert meters into both feet and miles. So we're going to write a function called meters to feet and miles. The 2 is, like TO. So convert meters to feet and miles. It's going to take in meters as an argument, and it will return both feet and miles in that order. And just as a reminder, there's 3.28 feet in a meter, 5,280 feet in a mile. So let's go ahead and test the function. And you want to make sure everything is spelled the same. So let's call this meters to feet and miles, and it's going to take in meters. And again, I have meters in parentheses, and then I need the colon. So we want to convert meters to feet, so we're going to return feet and miles in that order. So let's do feet equals, and then let's see, we've got meters, so we've got meters times 3.28, right? Because there's 3.28 feet in 1 meter. And then we'll have another variable called miles. And notice how Colab is indenting everything for us. Not every editing environment does that, and sometimes you may have to go back and change things. Make sure that everything is indented here, and that means it's part of this function. Okay, so miles. Well, I've already defined something called feet here. So why don't we just take feet and divide it by 5,280, and then we'll have miles. So I defined a variable called feet. I was able to use feet inside of this function, and then we'll return feet, comma, miles. And notice how I've got spaces between everything just for readability. I just want to emphasize you can have this without those spaces if you want, those blank lines, but I'm going to do this I'm going to at least put some spaces there just to keep track of everything. Okay? Now this is all in the same cell, so we don't want to run this just yet. We're going to test the function here, and I have a print statement. And this print statement is expecting you to get feet and then miles. And instead of typing feet and miles, I'm just going to use these variables because I don't want to type feet and miles all the time. I'll assign the output to F and M that stand for feet and miles. And so I'm going to assign to that the output of meters to feet and miles. And I'm going to type, this should be for 1,000. That's a mistake on my part. We want to test this out for 1,000 meters. And then I'm going to cut and paste this down here because we also want to test it out with 6,000 meters. And what I've done in these print statements is I'm printing F, which is going to be our feet, and then I'm printing M in miles. I'm using these F strings. And this colon 0.2f means that I'm going to assume that the number is a float, and the 0.2 means 2 numbers after the decimal place. So let's see if this works. I'm going to do Control Enter to run this cell, and I get feet. Okay, so 1,000 meters, 3,280 feet. Miles, 0.62. So 1,000 meters is a kilometer. And so 1 kilometer is about 0.62 miles. 6,000 meters, that's 6 kilometers. That's 19,680 feet and 3.7 miles. So notice that once I stopped indenting, Python knew that all of this up here is part of one function. And then once I stop indenting and I come down here, this is just like separate code. But it knows about meters to feet and miles, and we can just repeat it. I got 2 output values from meters to feet and miles, and I assigned that to two variables f and m. I could have called this a and b. I could have called it x and y. I could have called it Jack and Diane if I wanted to. But I've chosen f and m because that is easier for me to remember what those actually mean, which are feet and meters. Okay. Now these functions, this is a big gotcha with functions, and this is where it can be confusing. The variables inside the function can only be accessed inside the function if they're defined inside there, unless they're actually returned. So in other words, I'm returning feet and miles. Okay, these are the values for feet and miles, but the actual variable feet is defined inside here. And when I actually return feet, I'm actually just returning the numerical value of what feet was. So let's see, can I actually print feet? So I'm going to come down here and I'm going to try print feet, right? You would think, well, I defined a variable called feet. I should be able to. But what happens is I get this error. And it says feet is not defined. And that's because feet is only kind of like, Python is only aware of the variable feet while it is inside this meters to feet and miles. Once it comes out of here, I've called the variable f, and I've assigned a numerical value to it. But once I'm down here, I've forgotten about the variable feet. So we can't print feet, we can't print miles, and if you want to, you can try printing miles. Because they've only been defined inside the function meters to feet and miles. You could define those variables outside of meters to feet and miles and then use them, but right now they only exist inside that function. And this is referred to as the scope of variables. So think of like a telescope. Where does a telescope see? Think of where Python can see the variables. And scope and scoping is, again, not unique to Python. This is an issue with all programming languages. Where is the scope? Where are they defined? And that tells you where they can be referenced. And if you just need to remember, some mnemonic or something to remember, what happens in the function stays in the function unless you actually choose to return it. And even when you return it, you only get the value, not the actual named variable itself. So again, variables that are defined in the function are only usable in the function. We're going to try one more example of this just to drive it home, because it is one of the big sticking points when people are learning functions. So let's do a subtract function. So I'm going to define a function called subtract. It's going to take in two variables, a and b. I have the colon at the end. I'm going to define a variable in here called difference. That's equal to a minus b, and then I'm going to return difference. And then down here, let's see if we can use this. So I'm just going to print, I don't even have to assign it to a variable if I want to. I'm going to print subtract, and I'll pass in, let's say, 25 and 15. So if I print the output of this, it should return from this the difference of those two, which is 25 minus 15, which is 10. And I get 10 out. And now if I wanted to, I could try running this again, where I will print difference. And you might say to yourself, well, of course it's going to work because difference is in the cell here. I can see it right there. But I get an error. Because difference is, by the time I get down to this line of Python, difference has not been defined. Difference exists within this indented region inside this little Lego block. Think of this as just some little Lego block. And the fact that difference was defined inside that function, inside that Lego block, means that once I get down here, it is not defined, and that's why we get this error. Now, even though every time I've talked about functions, I talk about returning values and output, functions actually don't have to return a value. 99 times out of 100, they do return a value, but you don't have to. So to emphasize this, I've got this very, very contrived example. Let's write a function called this is so silly. And it's going to take in some string, these words, as its only argument. And again, argument is the input. It's not going to return anything. Instead, it's just going to print to the screen. It's going to print you said, then print the input words that someone passed in, and then print I'm rubber and you're glue. What bounces off of me sticks to you. So let's try this. So it's called, my function is called this is so silly. It's going to take in some words. Words are in a parentheses, and then I have my colon. First thing it's going to do is print you said, and then I'm going to put a little /n at the end. And remember, we learned before that /n, that \n with the negative slope, that means print a new line. It will then print the words that somebody passed in. And then we're going to print, actually I'll print words. I'll do another new line after that, comma /n, just for a new line. Here it went to I'm going to make sure that I'm indented here. And then I'm going to print I'm rubber and your glue. I'll do a little /line here. What did I say? What bounces off of me sticks to you. Like I said, this is a very contrived example. And now I do not have, I'll do an indent here. Just a little comment for myself. There is no return statement. And that's okay, at least for this example. Other times you may need a return statement. Most of the time you do. So we're going to test the function out here. I'm going to pass in I'm tired. We'll have a print for a blank line. And then I'm going to write computer, you're ignoring me. I'll do control enter. It says you said I'm tired. Program says I'm rubber and you're glue. What bounces off of me sticks to you. Then it says you said computer, you're annoying me. I'm rubber and you're glue. What bounces off of me sticks to you. Ha 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 ha. And there was no return statement. It just printed it to the screen. But I will say this, 99 times out of 100, you do need a return statement. Okay, you can use functions for pretty much most anything, and they are a lifesaver when you're writing really long programs. Whatever you're analyzing, you generally want to break it up into small chunks, in large part because those smaller chunks are much easier to debug because you can write little test statements for them. Okay. Let's talk about keyword or named arguments. So these arguments, these inputs, I've been calling them like A and B, but you can also have them named so that when you call the function, you actually refer to the arguments by name. What I mean is up till now, for instance, in this example here, I had subtract A and B, but I just passed in the numbers 25 and 15. Python knows that 25 will be assigned to the first argument and 15 will be assigned to the second argument. But we can give ourselves a little bit more control if we use keywords. If you have regular arguments, these keywords have to come after the normal or unnamed arguments in your function, and we can give them a default option. So default means if nothing is passed in, Python has an idea of what to use. It actually knows what to use if someone actually doesn't give it a value. And this only works for named arguments. So we're going to write a function called add and subtract. It takes in two numbers as input, and we'll make both of these input arguments keyword arguments for x and y. We'll give them default values of 10 and 15, meaning that if somebody doesn't pass in anything, it'll assume that x is 10 and y is 15. And the function should return the sum and difference of these input arguments in that order. Okay, so we'll define the function def for define, add and subtract. And then instead of just x comma y, which is what we've been doing, and then colon, we're going to have x equals 10 and y equals 15. So that means that if we actually don't pass in any numbers when we call the function next time, it'll assume that x is 10 and y is 15. So it should return the sum and difference. So the sum for adding them together, I'll use a, and that equals x plus y. And then subtracting them, we'll do s for subtracting, and that's equal to x minus y. We'll return a comma s because it should return the sum and difference in that order. Now we're going to test this out by using it in a variety of ways, just to show you how these are used. I've got a little print statement here as a reminder that the default values are x equals 10 and y equals 15. I'm going to have a and b be my return values, or my variables that I'm going to assign the return values to. So ab equals add and subtract. And instead of passing in anything, I'm just going to have open close parentheses. And you need those open close parentheses. You can't ignore them. Even if you're not passing in anything, it will think that it's not a function if you don't have those parentheses. And then I've got our print statements. It's an F string. If we don't pass in anything, we get A and B. I run this. So as a reminder, the default values are x equals 10 and y equals 5. This should be 5 there, just to remind ourselves. Boom. Fix that. Okay. So the default, if we don't pass in anything, we get 15 and 5. Now we're going to try giving x and y different values. So here, again, I'm going to do the same thing. A comma b equals add and subtract. And now I'm going to pass in x equals 18 and y equals 32. So I'm, instead of just passing in 18 and 32, I get x equals 18 and y equals 32. I run this, and we get 50, which is the sum of those two, 18 and 32, and then negative 14, which is 18 minus 32. Now the question is, can we reverse the order of these named arguments? I'm going to cut and paste that line. And what I mean by reversing the order is, can we write y equals 32 and then x equals 18? So instead of x equals 18, y equals 32, is Python smart enough to know that if we do y equals 32 and x equals 18 to still assign those variables? And it turns out we do. We get exactly the same values, 50 and negative 14, even if they are in different orders. So that is incredibly useful. Now, I'm going to add this in here. What if we don't reference the variables by name? So in other words, I'm going to have 18 and 32. Without referencing them by name. So I'm just passing in 18 and 32, and we get the same values. But at this point, if instead of 18 and 32, we did 32 comma 18, then we would actually get, 32, 18, we get 50 because that's the sum, but now we get positive 14 because that's 32 minus 18, okay? All right, and we can only pass in one value if we want to. So a comma b equals add and subtract. And here I'm going to pass in y equals 32, but I'm not going to pass in anything for x. We'll remind ourselves of what the default value is for x. It's 10. And so we should get the sum of 10 and 32 for our first value, and then 10 minus 32 for our second value. And we do. We get 10 plus 32 is 42, and then 10 minus 32 is minus 22. Awesome. So name values are incredibly useful. I use them a lot in my code. And again, just to emphasize, these functions can be used anywhere once you've executed them. So remember that example of add that we had at the beginning? I can use it here, even though it's much, much later in our program. So I could do x equals add, and then I'm just going to go blah, a bunch of variables or a bunch of numbers, comma, and then a bunch of other numbers. And then I will print x, and lo and behold, our function still works even though it's much later. Okay, so if you struggled with functions at first, I assure you we will be using them pretty much all the time, so you're going to get lots of practice. This is just the start. Don't freak out. We're all in this together. We'll get through this. It's going to be a good time. All right. Talk to everybody next time. Reach out to me if you have questions. Talk to you later. Bye.